So in this video we are going to discuss trigonometric ratios up to transformations. Page 285, example 4. The first bit, if a plus b plus c is equal to pi by 2, then prove that sine square a plus sine square b plus sine square c is equal to 1 minus 2 sine a sine b sine c. So in the solution, given that a plus b plus c is equal to a plus b plus c is equal to pi by 2. So what is given here? LHS. So the LHS is given sine square a plus sine square b, so plus sine square c, so which is equal to, what I am doing is here, so sine square a writing as 1 minus cos square a, and this sine square b is writing as it is, and plus sine square c is also writing as it is. So what is, I applied that here, we know that, so sine square theta is equal to 1 minus cos square theta. Sine square theta is equal to 1 minus cos square theta. So that's why here the sine square a, so I have written as 1 minus cos square a plus sine square b as it is, and sine square c is also as it is. Now what I am doing is here, one writing as it is, from these two terms taking clearly minus common, so then we get here cos square a minus sine square b we can write. So if you multiply this is with minus cos square a, and minus into minus is plus sine square b, so plus sine square c. See, what is the importance to take the minus common here? When you take minus common from both the terms, it comes under one of the formulae, known formulae, that is cos square a minus sine square b. See, we know that cos square a minus sine square b, the formula is cos a plus b into cos a minus b. So that's why you can apply this formula there. So for this we can write it as 1 minus, so cos a plus b into cos a minus b, and plus sine square c is writing as it is. Now which is equal to 1 minus, see already we have a plus b plus c is equal to pi by 2. So from this we can write it as a plus b is equal to 90 minus c we can write. So that's why, so here a plus b is replaced by 90 minus c here. So cos 90 minus c into cos of a minus b plus sine square c is writing as it is. Now see here, we know that here cos 90 minus c is like cos 90 minus theta. We know that cos 90 minus theta is equal to, so sine theta, which belongs to the first quadrant. So that's why here, which is 1 minus cos 90 minus c is, so sine c we can write, so into cos of a minus b plus sine square c is writing as it is. Now if you observe here clearly, from these two terms, you can take the minus sine c is common as it, minus sine c we can take the common. So now if you take minus sine c is common from these two terms, so we get 1 minus, so sine c taking common, so then we get here, so cos a minus b is as it is, so this cos a minus b is writing as it is, and here when you take the minus sine c common, here already plus is there, so then it becomes minus, so that's why sine c. See again, if you multiply with the minus sine c into cos a minus b, this is as it is, and here minus into minus is plus, sine c into sine c is sine square c, it remains same. So now again we know that here 1 minus sine c is writing as it is, into cos of a minus b, and minus here sine c. See here c is equal to, also we can write 90 minus a minus b, and further it can be written as 90 minus of a plus b. So here c is also replaced by, so 90 minus of a plus b, we can replace, c can be replaced by 90 minus of a plus b. So when you replace like that, again it is in the form of so sine 90 minus theta. So sine 90 minus theta is, we know that again it is belongs to the first quadrant. So we have cos theta only. Sine 90 minus theta is cos theta. Cos 90 minus theta is sine theta. So here sine 90 minus theta. So that's why that is cos theta. So now 1 minus sine c into. So this is cos of a minus b and minus. So this entire thing is can be written as per this property cos theta. Theta is what here? A plus b. Theta is a plus b. So that's why if you observe here within the bracket, so we have one of the standard formulae, that is cos a minus b and minus cos a plus b. Cos a minus b minus cos a plus b is equal to, we know that clearly 2 sin a sin b. So that's why here, so that is replaced by 2 sin a sin b. Now 1 minus sin c into, so which is 2 sin a sin b. So now further it becomes, if you multiply with minus sin c, then we get here 1 minus 2 sin a into sin b into sin c. So observe here, so which is only the RHS we required to prove, 1 minus 2 sin a sin b sin c. So therefore if a plus b plus c is equal to pi by 2, then we can prove that sin square a plus sin square b plus sin square c is equal to 1 minus 2 sin a sin b sin c. So therefore LHS is equal to RHS.